Alright, here's a problem where I'm given a position function and I want to answer a bunch of questions about its motion. So I want to first make a note of the fact of derivative of position is velocity and derivative of velocity is acceleration, so I've listed those here. So on the first two questions, when it's moving forward, when it's moving backwards, I want to know where's the velocity positive and negative respectively. So since you are allowed to use the calculator, what I would do is plot the velocity function on your calculator and just observe where it's positive and negative. Alright, so I've gone ahead and I've plotted it. So the other thing I'm going to do is I'm going to change my window. So here's the window that I've chosen to display this graph. I'm going to go from 0 to 10 on x and 0 to 20 on y. And if you look at this, here's the graph of the function. One thing you notice about this, hopefully, is that the velocity graph is never negative. Sorry about that. Let me just grab a quick copy of this. Alright, so that's the velocity graph right there. So I'm going to make a note of the fact that velocity is positive for t greater than 0, and so where is the velocity positive? When is it moving forward? Always. And so that means when is it moving backwards? It's never moving backwards. Okay, so the next question, C and D. When's it speeding up? It's where the acceleration and velocity have the same sign, and it's slowing down where acceleration and velocity are different signs. So here's a quick sketch of the acceleration function. I just went ahead and graphed it right on top of the one that I have. And basically, if you look at x equals 2/3, okay, on the left side of that, velocity is positive, acceleration is negative, and on the right side they're both positive. So from 0 to 2/3, it slows down so that it can change directions, or excuse me, not change directions, but it just slows down. And then, whoops, sorry, that's where they're different. And they're the same sign to the right of 2/3. Okay, so sorry, I misspoke a minute ago. When the particle changes direction, so that's the question for E. We're being asked to find where it changes direction. Even though it slows down when it gets to 2/3, it's still moving forward. And so once it gets to 2/3, it speeds up again, but it's still moving in the forward direction. And so, again, a simpler way of saying that, where does the velocity change signs? It never changes signs, so the answer to this is never. Alright, and then finally, to figure out the displacement, you're going to do the position function evaluated at 5 minus the position function evaluated at 2. Alright, so if you put these two values in, you're going to get 178 for s of 5, and you're going to get 10 for s of 2, which comes out to be 168.